All right, hello and welcome. In this video, we're going to look at how to set up a comparison between two inductors that are identical except for their number of turns. And so that leads us into our inductor equation that involves turns. That's our inductance is equal to the number of turns squared multiplied by the permeability multiplied by the area divided by the length. And so I've pulled out the permeability, area, and length from a different example in the textbook. And I'm going to use that as my stagnant part, as the part that does not change between the two inductors. And then I'm going to alter the number of turns to be able to evaluate what the inductance actually comes out to when we double the number of turns. Right? And that's going to give us two different values there. So first thing you have to do is figure out what you want your number of turns to be. And you're going to have two of them. You're going to have the first number of turns for the first inductor and the number of turns for the second inductor. And so you can set those to any value you want. And you'll plug that in up here. You'll say number 1 goes first, and then the L1 is out of that, and L2 will come from the number 2 squared, multiply the permeability, the area divided by the length. And so you can plug that into Desmos pretty easily just by plugging in these numbers here. Do that, we'll say that we want to put in the number of turns, and we'll say that as an n right now so that Desmos doesn't evaluate. We'll square that, and then I will multiply by the permeability. So I can open parenthesis here and say the permeability is 1.2 times 10 to the negative 6. And I'll close that off and multiply, opening another parenthesis there, by 10 times 10 to the negative 5th for our cross-sectional area. Move that over and do a double parenthesis there so that I can divide the entire thing by our length, 0.05. And that's going to give us the total output for inductance. So you want to put in your N1 in here first and square it and see the output of your inductor. And then you'll copy this, send this out, and do a second one here. And that'll be your N. So this will be your N1 up here. And this is your N2. Right? And so plug those two in, come out with whichever one is larger and then which one is smaller. Right, so evaluate those two numbers in comparison. You can even do a ratio between them, right? You can put whatever inductor comes out larger on top, and you'll evaluate whatever inductor comes out smaller on bottom. And that's going to allow you to compare them in terms of ratio. So then you'll get a factor out, and that'll tell you how much larger in terms of inductance that number of turns caused. Okay, let me know if you guys have any other questions.